Hi everyone, thank you for your interest in this talk. My name is Joaquin, and on behalf of my co-authors, we're going to talk about our approach to AI fairness at LinkedIn, how we disentangle and operationalize it. Imagine you're a recruiter searching for candidates for your job, and you find that out of 100 search results, only 20 are female and 80 are male. You could ask yourself, does this seem fair? Now, let's look at this under two lenses. If we ask ourselves whether the model is treating everybody equally, we could say when the model predicts real-world qualifications for the job, does it do an equally good job at it for males and females? And if the answer is yes, then you can say, well, these results are fair because the model was equally good for males and females when predicting whether they qualify for this job. Now, on the other hand, on the flip side, if you're aware that there have been historical barriers to acquire certain qualifications and skills for females compared to males, or if you are aware that there's bias where females tend to underreport their qualifications, then you might say, no, actually equality of treatment is not enough, and I want to ask questions about equality of outcomes, where the outcomes here should be that I get a distribution of males and females that is closer to 50-50. These two views would correspond to predictive parity on the one hand for equality of treatment and to demographic parity for equality of outcomes. Now, these questions and these paradoxes are not new. The AI fairness literature has documented that there exists a plethora of metrics that are both reasonable and mutually incompatible. And you might have seen this cartoon here that illustrates the difference between equality of treatment and equality of outcomes, and in particular with emphasis on the fact that most of the time you cannot have them both at the same time. Choosing equitable outcomes means not choosing equal treatment and vice versa. And these paradoxes exist in the mathematical, ethical, and political views of AI fairness. What are we to do about this? So at LinkedIn, we've decided to take on a holistic view where we incorporate elements both of equal treatment and of equitable outcomes. And we ask that AI models and practitioners focus on equality of treatment, but knowing that this is not sufficient, we also ask for a complementary product equity strategy that pursues equitable outcomes and that focuses on understanding potential harms or barriers that disproportionately affect certain groups. As an equation, AI fairness is equal to equal AI treatment plus product equity. We've codified this into three principles in order to operationalize it at scale across the company. The first principle commits to measuring and mitigating algorithmic bias from an equal treatment lens. The second principle commits to going beyond this and to building a broader product equity strategy. And the third principle says that we will validate our approach externally and we will be transparent about our work and results. In a little bit more detail, the first principle focuses on equality of treatment with AI. Mathematically, what this means is that if different groups share the same predictive scores or from an AI algorithm, we expect the actual outcome rates to be similar across those groups and independent of a demographic group membership. The second principle focuses on equity. One of the things we've been doing at LinkedIn is we've been collecting self-ID data where people volunteer demographic data for the purpose of research and product equity. And as an example of a research project we're running is we are experimenting with a feature in our recruiter product where we notify recruiters if the pipeline or the talent pool they're building is imbalanced and, for example, has a gender distribution that seems to be quite far from the baseline. And we'll encourage them to take actions such as change search criteria or maybe be more inclusive in their job description. At the same time, we know that the ability to measure AI fairness is limited by the data the AI algorithm has collected, and sometimes it might lock on to the head of the distribution and not explore the long tail of other people or pieces of content that might have met some qualifications. So what we do there is we have active exploration strategies to answer counterfactual questions. Finally, we have been validating our approach externally and are committed to transparency through talks like the one I'm giving here with Brian, and through our LinkedIn engineering blog post. We've been talking to academia, to our members and customers, industry partners, advocacy groups, civil society, and the Microsoft Responsible AI team. I'm now going to hand it over to Brian, who's going to walk us through a case study in detail. Thank you all.
Thanks, Joaquin. Hey everyone, my name is Brian, and I'll be going over a case study of how we applied these principles on a LinkedIn product that's a major source of profile visit traffic. This product is called People Also Viewed, and it's what's responsible for generating other candidate recommendations when you go visit a member's LinkedIn profile. So our case study will cover how we measured predictive parity fairness, mitigated it under a justifiability framework, and measured product and fairness metrics. For illustrative purposes, I'll be keeping the discussion to binary gender, males and females, but it's important to note that this generalizes to non-binary groups as well. So getting straight into the measurement, we identified the problem as model miscalibration. And what that means is that for a given score, it could mean different things in terms of the expected outcome, whether the model is scoring a male or a female. And this is an undesirable property, as it means the model may systematically underscore a certain group. To mitigate this, it was very important for us to follow a justifiability framework. And what I mean by that is, although we knew from early on that using gender as a feature in the model could close this gap, it was important for us to make sure that we have checked other alternative mitigation schemes before we jumped to using gender. This included things like trying out general mitigation strategies of calibration or feature selection or calibration-focused loss functions. But ultimately, we found that using gender in a post-processing per-group calibration scheme performed the best. And we were able to justify this use based on the inadequacy of the other approaches that we tried. So we actually launched this solution in an online A/B test, and we found that it significantly improved the equal treatment metric, which you can see on the graphs in the bottom left-hand corner. And critically, we also saw an improvement in the product metrics in terms of profile actions. So this is an amazing case where we saw that equal treatment need not sacrifice model performance. Still, it's important to know what's actually going on the ground, and we do this by measuring unintended consequences. Specifically, we knew that our mitigation strategy would boost the scores of female members, which may push them higher in ranked lists, which is usually good, but could also expose them to things like unwanted invites or spammy messages. So for all of these kinds of fairness interventions, we will work with engineering and product to figure out what types of unintended consequences could occur and measure them accordingly. In this specific case, we did a network edge level analysis to check if the adverse response rate coming from females based on the experiment was much more than the global average based on the control group. Fortunately, we did not find any, and so we concluded that there were no unintended consequences from boosting female profiles. In summary, Joaquin and I have used this talk to set forth our 3 principles of operationalizing and disentangling fairness. First of all, we'll measure and mitigate our AI models to move closer to equal treatment fairness. Second, we'll complement our work with responsible AI in products as well to upheave historical barriers and measure unintended consequences. Third, we'll lead with transparency and externally validate our methods and principles through talks like these. We also presented a case study in which we applied these principles on an important LinkedIn product, and we found improvements in equal treatment, improvements in product metrics, and no detection of unintended consequences. We hope that this talk gives you a ground zero perspective of how we principally think about, measure, and mitigate for fairness gaps at LinkedIn. We invite you to check out our paper in more detail, Disentangling and Operationalizing AI Fairness at LinkedIn, and we thank you so much for your time and for listening to our talk.